The periodic table contains a lot of information. We're going to look at some general features of the periodic table now and get into more depth later on in the course. The first thing we want to notice about the periodic table is that it's set up by rows going across and columns going down. The rows going across the periodic table are called periods, and the columns going down are called groups or families. And because the elements that are in a particular group have characteristics in common, they're sometimes referred to as families, and they have particular names. So our first group or family are called the alkali metals. And alkali metals have one valence electron, or electron in their outermost energy level. That makes them reactive, and in order to become stable, they're going to tend to lose one electron. And when they lose an electron, they form an ion with a +1 charge. The second group or family are called your alkaline earth metals. They tend to have two valence electrons. So in order to become stable, they're going to lose those two electrons and form ions with a +2 charge. Now this middle section on the periodic table are called your transition metals, and they tend to have varying charges on their ions, so we won't look at those right now. But the elements that are in this group here, which is sometimes referred to as group 13, it's sometimes referred to as group 3, or sometimes it's called the boron group, has 3 valence electrons. And since it has 3 valence electrons, it's going to tend to lose those 3 valence electrons in order to become stable and form ions with a +3 charge. Now we're going to move over to the far right on the periodic table for a minute, and all the elements that are in this column here are referred to as noble gases. And from neon down in this particular group, all of these elements have 8 valence electrons. That makes them stable. They don't form ions. Helium's a little bit different because it only has 2 valence electrons, but it also has a stable electron configuration, so it doesn't tend to form ions. But if we move one column over from the right, we're looking at the halogen group. Now this group has 7 valence electrons in it, so in order to become stable, it tends to gain 1 electron and form an ion with a -1 charge. If we go over 2 columns from the right and we look at what's sometimes referred to as the oxygen group, they have 6 valence electrons, so in order to become stable, they tend to gain 2 electrons and form a -2 charge. If we move over 3 columns from the right, now we're looking at what's referred to as the nitrogen group. They tend to have 5 valence electrons and gain 3 electrons to become stable. So they form ions with a -3 charge. So we've got +1, +2, +3, -1, -2, -3 for charges on ions. Now right in the middle here, our carbon group has 4 valence electrons. So it could lose 4 electrons and form ions with a +4 charge, or gain 4 electrons and form an ion with a -4 charge. And oftentimes they don't do that, they do something a little bit different in order to become stable. And we'll look at that later on. Now we're going to look at how to write formulas for compounds. And we're going to look at the first type of compound today, which is called binary ionic compounds, or we'll classify them as type 1 compounds. Binary means that these types of compounds have only 2 types of atoms in them. Ionic means that we're going to be looking at ions, so we know how to use our periodic table to find out the charges on ions. And the term compound means that we've got 2 or more atoms that are chemically combined together to form a coherent unit. When we look at binary ionic compounds, they will contain a cation, which is something on the left side of the periodic table, combined with an anion, which is something on the right side of the periodic table. So cations tend to lose electrons in order to become stable, and when they lose electrons, they become positive. Anions tend to gain electrons in order to become stable, So we have anions, negative ions, and positives and negatives attract each other, and that attractive force is what holds binary ionic compounds together. When we name binary ionic compounds, the cation is always named first, and the anion is always named second. Now for the cation name, we're not going to do anything to the name of the ion. So whatever the name of the element is that ion is forming from, that will also be the name for the cation. So if we had a sodium atom that loses an electron and becomes an ion, it'll be called sodium. If we have a calcium atom and it loses 2 electrons, it'll become a calcium ion. But negative ions are a little bit different. If we look at monatomic anions, or negatively charged ions made up of only one type of atom, we're going to change the ending on the name of the element. We're going to take the ending on the element, drop it off, and replace it with "ide." So if we have a chlorine atom and it gains 1 electron, it will become a chloride ion. Or if we have an oxygen atom and it gains 2 electrons, we'll have an oxide ion. Now let's look at how we go from formulas to names. And really all we need to know for binary ionic compounds when we go from formulas to names are the names for the ions. So if we have Li, it's a binary compound because it's only got lithium and iodine in it. It's ionic because lithium is on the left side of the table, iodine's on the right side of the table, so they will form an anion and a cation. So when we name it, we need to know what the names of the elements are. Li is lithium, and we know that we're not going to change the name when it becomes an ion. I is iodine, but when it becomes an ion, we'll change the ending to "ide." So the name of Li would be lithium iodide. AgBr, binary because it's 2 types of atoms. Ionic because it's something on the left combined with something on the right. Ag is a little bit of an unusual symbol, but it's a symbol for silver. Br is a symbol for bromine, but when it becomes an ion, we'll change the ending to IDE. So our compound is silver bromide. Kf. K is potassium. F is fluorine. We'll change that "ine" to "ide." So potassium fluoride. Now this one has numbers as subscripts, but it's not going to do anything to the name of the compound. Lithium is on the left side of the periodic table, nitrogen's on the right side of the periodic table, so our name, lithium nitride. And our last example here would be MgO. Mg is magnesium, O is oxygen, so our name for our compound is going to be magnesium oxide. Now let's go from names to formulas. And here we're going to have to think a little bit about whether the atoms in that compound are going to be gaining or losing electrons, and how many electrons are they going to be gaining or losing. We'll use sodium chloride as our first example. So we know that our symbol for sodium is Na. When we look on the periodic table, sodium's an alkali metal, so it has 1 valence electron, and it's going to tend to lose that electron in order to become stable. Chloride comes from the atom chlorine. It has 7 valence electrons, so it needs to gain 1 electron in order to become stable. So if sodium loses 1 electron, it becomes stable and an ion. If chloride gains 1 electron, it becomes stable or an ion. And we know that positives and negatives attract each other, and that would be the force that would hold those ions together in that compound. We need 1 sodium and 1 chlorine to make both of those atoms stable, so our symbol would be Na1Cl1. And those ones are assumed. We don't need to write it, so we could just write NaCl. Calcium bromide. Our symbol for calcium is Ca. When we look on the periodic table, it's an alkaline earth metal. It has 2 valence electrons, so it's going to want to lose 2 electrons in order to become stable. We've got bromide. Bromide comes from the atom bromine. Bromine is a halogen. It has 7 valence electrons. It's going to need to gain 1 electron in order to become stable. So now we don't have a nice balance like we had in the example above. Calcium needs to lose 2 electrons, but bromine only needs to gain 1. That means we're going to need to have 2 bromines for every 1 calcium. So our formula would be CaBr2. The 1 is assumed, so we won't write it. Now, a trick for writing formulas, you don't necessarily have to think about how many electrons are gained and how many electrons are lost. When you go to write the formula for a binary ionic compound, you're going to take the charge or the number on top and drop it down here, and the number on top and drop it down here. So you would need 1 calcium and 2 bromines. Let's say we've got lithium nitride. We know our symbol for lithium is Li. It's an alkali metal, so it tends to lose 1 electron in order to become stable. We've got nitride, which comes from a nitrogen atom that has 5 valence electrons. It needs to gain 3 electrons in order to become stable. So lithium will form a +1 charge. Nitride will form a -3 charge. So again, we don't have that nice even balance. We're going to need to have 3 lithiums for every 1 nitrogen. Or we can do this crisscross method and take the 1, write it as a subscript down here, and the 3, and write it as a subscript down here. So our formula for lithium nitride is Li3N, and again, that 1 is assumed. Now let's say we have aluminum oxide. Aluminum is Al. Oxide is O. Aluminum has 3 valence electrons, so it's going to tend to lose 3 electrons in order to become stable and form ions with a +3 charge. Oxygen is going to gain 2 electrons to become stable and form an ion with a -2 charge. Again, it's not a nice even balance here, and the electrons that are lost by the metal that becomes a cation have to be equal to the number of electrons that are gained by the nonmetal to become an anion. So what we're going to do is we're going to take the 3 and drop it down here as a subscript, and the 2 and drop it down here as a subscript. So our formula is going to be Al2O3. Now think about that. Each aluminum is going to be losing 3 electrons, and we've got 2 aluminums. That means a total of 6 electrons are being lost by the aluminum. We've got a -2 charge on the oxide, which means that they're each going to gain 2 electrons, and we've got 3 of them, so 3 electrons are being gained by the oxygen. So the electrons gained are going to equal the electrons lost. And the whole compound is neutral. Now let's look at one more example. Let's say that we've got magnesium oxide. Magnesium is Mg. It's an alkaline earth metal, so it's going to form a charge of +2. Oxide is O. It's going to need to gain 2 electrons to become stable, so it's a -2. We're going to crisscross those numbers, and if we did that, we'd get Mg2O2. But when we write binary ionic compounds, these numbers are going to be in the simplest ratio. So we can simplify 2 to 2. Our formula is going to be MgO. We have 1 magnesium that's losing 2 electrons, and 1 oxygen that's gaining 2 electrons.